Quick bio for those of you who don't know me. I actually worked on Dart way back in 2012. I added SIMD to the Dart language. Then I spent many years working on the developer tools like the service protocol, the profiler, the debugger, and various compiler optimizations in the VM. Then 2017, I made Hot Reload, the feature in the Dart VM, which I think Flutter developers use often. Sure. Thank you. Yeah, it was a fun time, very fun time. Then I went and did an unrelated internal project at Google called Plaque. It's a programming language for programs that, like a single invocation, will execute over 1,000 machines. So, like 1,000 different servers participating in the execution of a single program. It's an interesting language, but I can't talk about it at all. And now I'm back on Flutter. Very excited to be back on Flutter, and I'm now the TL of Flutter. But I've had this side quest to fix Android platform views, and boy, is it actually tricky. So first I'll give you all an introduction to platform views in case you're unaware, although I don't know why you're here if you don't know what a platform view is. So imagine that you have a Flutter app with a whole widget tree, but you need to show some legacy Android view inside of it. That's what we call a platform view. It's when you have a mixed application where you have some Flutter widgets and then some native widgets. I'm going to focus on Android, but this is also the case for, say, iOS and other platforms. All right, so why do we need platform views, right? Okay, so Flutter apps need a browser widget. They need a maps widget. We cannot build you a new browser engine and a new maps engine. That would be ridiculous. And why would we, right? Video players, ads, that's how we display ads inside of a Flutter app. It's via platform views, showing an actual Android view hosting the ad. And then things like Unity and custom engines and old legacy software, sometimes you just need to slide it in. But it's a difficult problem, and I'll just sort of go quickly through a bunch of the areas in which this is challenging before I talk about the different ways of which we've implemented things. So input events. Android has this new concept called verified input events, and this means that the actual tap event that you deliver to the Android view is the original event that you received from the operating system. This caused a lot of issues for us because the way Flutter processed the input events, it would basically take the Android event, pass it to the framework would run it through the widget tree and re-deliver it to the Android subviews as it should. But at that point, we were using a new event, and then we failed the verified input events test, and this is going to be used in future ads SDKs to make sure that the clicks are not fraudulent. Flutter supports a pretty arbitrary set of widget transformations that you could apply. Android does not. And so we can get into these situations where you have in your Flutter widget tree, you have a platform view and you provide a 4x4 matrix, and there's no way to actually map that to something that Android can support. We're just more expressive. There are subtle event dispatch semantic differences between Android and Flutter. There are scrolling offset issues that we have to deal with. It's tricky to pretend that this Android view is actually part of your Flutter app. In a way that feels like exactly the way it would if you had a fully native Android app. So composing mixed content. So, we could see here, we have this screen that's showing some Flutter content and some Android content. And there are basically two different ways in which we can achieve the final compositing of the image that's displayed. Flutter can do it, which is ideal because the Flutter engine can render things in any, with any transform applied, and we know it all works. The other way is Surface Flinger. This is Android's native compositor. Well, it's not technically a compositor, but for the purposes of this talk, I think we can refer to it as such. But Surface Flinger has limitations, like the things that it composes have to be rotated at 90-degree angles. So essentially you can just flip the X and Y of your pixel data. You can't actually just say like, hey, rotate it and skew it. And there are performance trade-offs that come with each compositor mode. If Flutter is the compositor, then we can end up dropping frames from the platform view. This is particularly noticeable if you have, say, a full screen browser widget and you scroll really quickly. If you do this in Chrome, it's very, very smooth. As a platform view inside of Flutter, it can be smooth. Sometimes it's janky. Other times there's not an opportunity for us to synchronize here. And so we end up just sort of getting most frames but losing some. On the flip side, if we have Surface Flinger composite the image, then Flutter content drops frames. And there's an extra copy of the Flutter image, slowing down, adding latency and increasing overhead of the Flutter view. Robustness. Surface views. I don't know if anyone in the room is aware of what a surface view is inside of Android, but it's a very particular view that actually just punches a hole in the screen and lets you show a texture behind it. A lot of our solutions for platform views on Android support everything except surface views, because surface views are truly special and it's something that Surface Flinger itself manages. Android is not actually painting that texture. Surface Flinger is, like your app isn't. If you update your platform view off the main thread, say it's an OpenGL game or something like that, you have to notify Flutter that the frame is updated. We won't get a notification from the operating system. So that's sort of like, we have a way to make this robust, but it means that we have to subject you all with the cognitive load of like, oh, okay, I have this particular type of Android widget. I need to make sure I add this like little bit of Java code to like kick the Flutter renderer and tell it to repaint. Some of our modes have broken accessibility. Some of the modes have a broken like text zoom, when you hold your finger down and you see that little thing there. Depending on how the platform views are configured, you'll see the text or you'll see blank. And I'll just say, like, on this, it's like, unfortunately, historically, the decision has been to subject you all with the complexity of like all of these different modes, which I don't think is the right posture for us to have. And so right now, it's like, if you want to do a platform view on Android, you sort of need to know about all of these different trade-offs that you're making, and then use the appropriate widget, when really, like, we should be managing all of these details for you and just giving you a simple widget that works. So hopefully that's where we'll get to. Reliability is an interesting problem, and I'll give you two examples where platform views on Android were broken, but the Flutter project can really claim like we did nothing wrong. So the first one was, this was in the summer, fall of last year. Google Maps is sort of built into the operating system, and the team does a lot of these like, oh, let's do this experiment to 3% of users and see what happens. And so there's some experiment that changed their threading synchronization of their renderer. And it eventually got ramped up to 100%. And this change broke Flutter apps. Like the Google Maps inside of a Flutter app would just like sort of stutter back and forth between two different frames. And this was like silently pushed out to phones. Like it didn't require the Flutter developer to like update their app or rebuild anything or relink. It's just like magically we're modifying the behavior of this code that's already been loaded onto the phone. So it took about a month after it hit 100% for like some bugs to come in, and then for us to root cause this, which was kind of tricky because there's like thousands of experiments that Maps uses. And anyways, the Maps team was super helpful. And once we did root cause it, they turned off the experiment, and within 24 hours, like everything goes back to normal. great. But unfortunately, like that's awful, right? Like your app is out there and it's like perfect and it's fine and you don't need to update it. And then magically you just get broken by this background thing. This can happen to regular Android apps as well. So it's not Flutter specific, but it's just something that we have to deal with and remain very vigilant about. On reliability, last year we had a really interesting, well, it started last year and it ended up going into this year. Very interesting bug report where the TLDR of it is after backgrounding your app, sometimes, and only sometimes, after you resume it, the platform views will just be blank. And, you know, after knowing everything, after truly root causing it, we know that like the commit into the Android source code that broke this landed 6 months before anybody noticed. And the first place that we noticed it, it was only on Android phones, only on Samsung phones running Android 14. And so we spent a couple months working with the Samsung folks under the false impression that this was a Samsung specific change that ended up breaking the apps. Ironically, we ended up fixing a different bug in the Samsung graphics stack that probably was impacting us, but didn't end up being the actual bug. Because eventually, like Pixel phones got updated to this specific build of Android 14, and then we started to see it everywhere. And then we, took a while to root cause it. The Android team was skeptical at first. They, as always, we're always like, the bug is not in my code; it is in how you're using it. But eventually, we actually bisected down to the specific day of the year that this commit was landed and broke this situation. So we've fixed it in Flutter 3.22. That includes a workaround for this Android 14 bug. But if you have an old Flutter binary uploaded to the store, it's broken on Android 14. If you have a platform view and if it is on the screen between suspend and resume, it's not like everything is broken, but the only way to fix it is for you to update, because this is actually just like the bug is in the Android operating system. It's also fixed in Android 15. It's fixed in, the bug wasn't there in Android 13. Some phones will get an Android 14 update that includes the fix, but most will not. That brings me to the next part that makes this a difficult problem, which is the cross-version compatibility. So Android is heterogeneous across versions and vendors. It turns out that like Android 14, like every phone vendor's version of Android 14 was cut from the branch at a different point in time. They pull fixes sometimes they don't. It's sort of just a grab bag, which makes our job hard because we're trying to run on everything. Like Flutter supports Android versions back to 21, which is about 13 years old. And so we have this issue where we need to remain compatible and run on old phones, but then also try and take advantage of new APIs to provide a better experience on Android. By the way, how are we doing Q&A? Is it afterwards? Or, if people want to ask questions, go ahead too, I don't care. But if there's a particular way in which the conference is doing it, then we'll do it afterwards. All right, okay. I'll take silence as people can ask me questions whenever they want. All right, so now I want to talk about the different implementations. So this is like a rough timeline. We start with hybrid composition, and I'll explain what all of these things are in a moment in more detail. But essentially, hybrid composition leaves it to Android to do the drawing and composite the image. Texture layer hybrid composition is a pretty interesting idea, and it sort of provides the best of both worlds, but it has limitations and issues, and unfortunately shipped without people realizing that surface views are special, which then led to virtual display-based texture layer hybrid composition, which is a lot. But they're essentially the same thing with one kind of critical and unfortunate difference. And then finally, we're getting to this new tech, which I'm just calling hybrid composition plus plus, because it's mostly what hybrid composition is, but with all of the unfortunate limitations and performance bottlenecks removed. So this is like on the left here, we have like the Android view hierarchy, and then in the upper right there, there's just a little like, this is what it is. So we've got a Flutter widget tree, and if you don't have a platform view, then there's just a surface view that is displaying the content that Flutter renders. It's very efficient. Again, surface views just like don't draw themselves, and Surface Flinger just like slides the actual texture in at composition time. So then let's say that we add an Android view, a platform view to the app. Dynamically, the engine will switch the surface view hosting the Flutter content to an image view. And then put the platform view where it would be actually in an Android application. So then what happens is like basically the Android app is rendered as it normally would be and composited by Surface Flinger. Unfortunately, the image view adds a lot of overhead and latency, unnecessary texture copies. It's an opportunity for us to drop frames. It's just not that performant. But the nice thing is like the platform view is just rendered exactly as it would be by Android. And the Flutter content is there, and it's reasonably performant. So in hybrid composition, the Android view hierarchy actually includes the platform view. As I said, all event dispatching is normal, all drawing is normal. It's basically, platform view is nothing special in hybrid composition mode. So this brings us to texture layer hybrid composition mode, where the platform view is handled very carefully so that we can control the drawing. So note that here there's a border around platform view because it's essentially a separate surface that Android is rendering. Here there's no border. So it's rendered with a texture widget, which is just a standard widget that Flutter ships with that allows you to point at some external texture, a Vulkan texture, a metal texture, an OpenGL texture. So like just render that in this rectangle for me. And so that's great. Now we're actually painting the platform view onto the screen, which allows us to support all of the complicated graphics effects and transformations that can be applied to the widget. It's pretty nice. And so here's how we do it at a very high level. I'm trying to give you all intuition here, not like go into like boring code level details. So we have an Android view, which we call the platform view wrapper. It's a pretty great name. And essentially what it does is it overrides the draw method, which is a standard Android view method. And you're given a canvas to paint on. And this canvas is typically associated with the main window of the Android application. But in texture layer hybrid composition mode, we actually just like, we don't use the canvas passed to us by Android. We use our own canvas, which ends up like piping the stuff that's painted into a texture eventually. This works for all Android views except Surface View. So it's almost perfect. Unfortunately, there are multiple threads involved and poor synchronization, so you can get into some janky situations. But for a lot of platform views, this is very performant and flexible and is generally what you want to use. But then there are some platform views where, like, again, that full screen browser where you're quickly scrolling, where it doesn't feel as good as it should. So surface views are not supported in that mode because they're not actually drawing onto that canvas that we're stealing and telling it to draw on. They're just drawing, they're filling that canvas with transparency, and then the operating system is going to slide the texture in behind it. So the way that this is worked around is we create a virtual display. And this is like an Android API that basically allows you to make a new monitor. That monitor is backed by a texture, not actually backed by any actual like display hardware. And because the monitor itself, because the display itself is being captured, this allows us to support surface views, but it's surface views with like an extra frame of latency and copy that has to happen as we copy it out of the virtual displays, screen, and into our own texture and then render it. Also comes with some other problems, like accessibility just doesn't work right. In a virtual display case, the view hierarchy is disjoint. So like the platform view should be in the normal view hierarchy, but it's not. It's actually been like shunted off into this totally separate view hierarchy that's running on a different display. Usually this is not a problem, but some apps are actually like walking up the view hierarchy and then they reach this point where they're like, this parent node should be there and it's not there, and I'm, don't know what to do. But yeah, essentially we go from the view hosted in a separate hierarchy to the virtual display output to a canvas, which goes to an image, which is then a hardware buffer and then a GPU texture. So that Android 14 bug that we're talking about earlier, essentially it breaks where that X is. So we would render to the canvas and it would succeed, but it would never produce a new image, so we would never get a new hardware buffer and never update the texture contents. And unfortunately, the workaround required to fix things on Android 14 actually had to leak into our public API, which just I think is terrible. Like you all will be subjected to complexity in order to work around a bug that is only going to exist on some phones on one version, but it is the only way in which we can actually make things work reliably. So now we get to hybrid composition plus. And so this is built on some new APIs that Android is adding in 34 and some in 35 and then some 36, which allows us to use hybrid composition where like everything is on the screen as it should be and is handled by Android correctly, but keep the Flutter content in a surface view and have essentially like a layer of surface, like a layer cake of surface views. Surface views are very efficient. Surface Slinger loves them. And so we can just stack today up to 3, in the future as many as we need of these, and then actually just sort of have Android itself manage piping the output of that Android view into a surface view that the system can composite. It has, this is like perfect input forwarding, supports surface views without special casing. It really should be like the it should support everything that we care about and be performant and robust. And I sort of like it because we're doing very little. Most of what's happening is actually just handled by the operating system. Fortunately, this API is only introduced in 34. We need things from Android 35, and there just is no API to order surface views. Well, there is, but it's two separate bools that you can set independently, which allows you to sort of address 4 different surface views and order them. But that's not enough because one of those surface views is taken by the operating system, and people can layer things however they want. Anyways, in Android 36, which is coming out at the end of 2025, we will have the API needed to properly layer these surface views, in which case we'll be pretty robust and resilient. But again, like we have to support Android back to 21. And so the legacy modes in which I've sort of talked about, they're going to be around forever. Like I think I might be retired before we can actually delete the code, which is a good thing and a bad thing, I guess. So just sort of giving a rough comparison here of the different modes and the issues that we face here. Hybrid composition mode has overhead for Flutter content. It doesn't have overhead for Android content. Accessibility works, verified input events work. It's pretty good, except that Flutter overhead is heavy. TLHC, there's no Flutter overhead. There's some Android overhead as we're like jumping across threads and getting the view content into a texture. Because in TLHC mode, the view is actually on the, like in the view hierarchy where it would be. Things like accessibility works and mostly verified input events work depending on the transformation applied. Virtual display, TLHC is just this weird thing that is only ever used when you give us a surface view. If you don't give us a surface view, we're never going to use this mode because it just comes with a lot of downsides. And then hybrid composition plus, which is, in that famous Google way, it's like the old way is bad and busted, don't use it. The new way is not done yet, but I promise it fixes everything. Anyways, we're working on it, and the prototypes are very promising, and we have great engagement from the Android team right now. So we are working together and building the right API so that we can just support this in a really clean and reliable way. All right, that's it. Questions?